Hello and welcome to my layout review. In this video I'll try to debunk all the theories behind the different layouts or different ways you can arrange your water cooling system to gain benefits or not. Yeah, there are some fundamental rules you should follow. Let me open this up. Some fundamental rules you should follow in terms of layout, but then, to be honest, all or most layouts should work. There shouldn't be any major issues, and that's due to the heat capacity of water, the heat capability of water. The heat carrying capability of water means that you can either go via your GPU first to the CPU, to the motherboard, then back to or you can go to radiator first. You can twist the layout any which way you want and still gain some benefits. And in order to prove this, right, I'm going to do a test. I got, if you can hear that clacking sound, that's from this this flow indicator. It's very noisy, so I decided to change it. It's tiring to have that constantly ringing by your ears, so I decided to change it and get something better. Well, I got this one, right? It's a bit power flow indicator, and it seems to be a much better make, and definitely would be silent. So I'm going to swap that for this, and while I'm doing that, I intend to change the layout a bit, because it looks like, what do I call this, Spaghetti Hill Junction down there. It looks a bit all over the place. I guess it could be a lot simpler and shorter. So I'm going to do some modifications to the whole layout and change the tubing. While I'm doing that, then change the liquid color. It has a green tinge. I think it's from the radiators, from the last liquid water cooling stuff I used. So let's get on with it, and I'll see you guys in the next video. But before I do that, I'll run a benchmark right now to show you the temperature difference in between this layout and the new layout when I finish it. The new layout will be like the most radical layout I've built ever. It will come from the pump to the radiator, right, all through both radiators, then go to the GPU, CPU, and make its way around the system that way. So it will be there'll be a marked difference between this and that one, this layout and that one. All right, let's just run the benchmark. Okay, running Heaven benchmark on Windows 8 with the old water loop configuration. So I'll just benchmark it and see. There we go. So let's run the benchmark. Can compare it against the Windows 7 one I did earlier on. And that's the power usage, CPU usage, GPU, and temperatures. CPU's never used a lot on this, just always about 10-20%. system. Results. Okay, close. Okay, it took me a day and a half, but we are back, baby. We've updated the layout of the system, added the new flow indicator, so everything's up and running as it should be. I didn't blow anything up, which was good. But there we are. Before I show you the computer as it is now, I guess we'll run the same benchmark. Let me just go through what's going to happen. We'll run the same benchmark as we did on the old system with the old layout, and check out the temperatures. Then I'll run a separate benchmark which I want to run here, because I found out that there's no single, except if someone knows, they should let me know, single program that can fully test out this system. So what I can do is I can run this program. Where is that? OCCT. I can run it on the CPU benchmark side to test out 10 of the 12 threads that the processor has, then use the other 2 threads to run Heaven benchmark, or test out or switch it in whichever way I feel would make it work. And Heaven benchmark would test the GPUs flat out, while this would test the CPU flat out, and I can check out the temperatures. But unfortunately I didn't do that on the old system, so I have to keep everything sensible and use the same benchmark and setup I used previously. So let me show you the new setup. Voila. Okay, some reflection on the screen, but nothing too bad. Take it all apart. So I went for clear acrylic, as you can see, but the layout is a lot more simpler than before, if I can use that word. If I will walk you through, I've installed the pump here now, just above the fan, right? Just above the bottom fan on the bottom radiator. So the pump is directly under the reservoir, and that goes straight into the first rad, from that into the next rad, from that to the GPUs, from that to the CPU, to the VRM, then back into the reservoir. So it's a lot more straightforward, and if you take a whole view of the system, you can see it's a lot more simpler. It's a simpler setup, and less tubing was used, I used half of well, I've gotten better at bending acrylic now, so I didn't have so much waste. But then I used half of what I used to use previously in making up a new setup, and that says a lot. This was difficult to do. This I had to do this about 3 or 4 times to get it perfect. I did it just once, but I could have done a better job if I'd done it a bit wonky, but then I'll leave it like that. This one was easier to do, just straightforward. And this one, about 2 or 3 times I used to get that the way I wanted. The others were straightforward, just 90-degree bends with a little kink in them. But then it looks lovely. There's a new temperature probe here, and this connected straight to the motherboard to show the heat of the whole system after the liquid has gone through. And this temperature indicator here is used to see the efficiency of the radiators and fans, and that's connected to this display. For now, I have no other place to keep this display, so I'll leave it here for now. Every other thing is as is. I didn't change no new components were put into the system. Everything just as is, I guess. Okay, so let's proceed with the benchmarking and temperature monitoring, I guess, and take it from there. So I'll close this for now. Where's heaven? Now why that boots up? Let's set this up. Yeah. So as at now, everything is as it was before. The overclock is still at 4.4 gigahertz max, although it's throttled, so you can see it's at 1.5 right now. The the power usage is still just like as it was before. The GPUs are still overclocked to about the same as they were before, and this is just as is this monitoring system that tells me what else is going on. We use 2x anti-analyzing like I did before. Everything is still as it was and run. So we can then monitor the temperature and the efficiency of the cooling system now with the new layout design. Like I said, it goes from it's the most radical I was going to do. I've never done this before because I always thought mechanically, but when I sat down to think about it, the temperature difference will not be much. This is what I expect. The temperature difference will be very minimal, if anything. Across the components, there might be slight changes, but overall, the temperature of the liquid will remain the same. So let's hit the benchmark button and voila. So it's benchmarking now. Let's see, what does this say here? Okay, and now there's the important bit. Yes, you can cross-check with the last time to see if the power usage has changed, but I believe it should be the same. Nothing else has changed in that front. As usual, nothing tests the CPU properly. I'm always at 15 to 20% or so. The temperature had just started to rise about 32 degrees on the CPU, so you can compare that against what happened last time with the old layout, because I expect the CPU temperature to change slightly because the coolant doesn't go directly to the CPU now like it did before, and the GPUs have ramped up obviously to their max megahertz setting, which is 1456. I like that number. It's running the benchmark as expected, so coolant has gone up to 30 on the outlet from the radiators. Just open that reflection, it's not so great. And here the fans. As I said initially, I set up some of the fans to ramp up when the temperature gets to a certain level. So right now the temperature is creeping up, but it's low. All the inner fans are running now, and the outlet fans will pick up when the temperature gets to about 32 degrees on this temperature indicator monitor. might have to run this test again because it's not even, temperature is not even going up at all. CPU is at 35, but it's doing absolutely nothing. So GPUs are at max. As expected, the power usage is right up there. So, let's benchmark. Let's see what the frame rate is doing. Okay, all the fans have started up. All the temperature has gotten up to what I expected. Yeah, the external fan, one of them is on. The second one should be coming on very soon. There's 1 degree difference between both of them. But there we are. The temperature is slightly creeping up slowly as the GPUs warm up. Okay, the benchmark is about finishing now. You can see temperature of CPU is about 42. I think the last time was around 40 something. But from what I'm gathering here, the temperature difference is not much between this layout and the last one. The score is just about the same. That was 922, I believe. This is 938, so just about the same. Let me run the benchmark again now that the system has warmed up to see if that changes anything. Yeah, the temperature of everything is woken up now. The fans are all running as they should be. So let's see if there's any difference. Temperatures remain exactly the same. The GPU temperature is about 45, 46 I think, but that's running flat out. I'll compare that temperature against the last time, but I don't think anything would have changed with that. I think the system has taped out at 33 degrees on the outlet, so the inlet should be anywhere between 34 35. I think I can find the inlet temperature here. Yeah, it's 34. That's the T sensor. And there's T sensor 1. It's 34, 35. I think it's going from 34 to 33, just cycling away that way. And all the fans are not yet at max. They keep throttling up and down. So I think the cooling is about it's reached a range where it can just about keep up with what the heat output from all the equipment, all the components. So it's all tapped out at a certain temperature, which is that 33, 34 area. Well, I believe there's a discrepancy between both temperature probes because they are both different from different companies, so there might be out a bit. So there's some error in between the inlet and outlet. I'll have to go back to my old phobia probe on the inlet side. We'll see. Okay, so in conclusion, this roundup, I don't think anything will change much. In conclusion, we can say that whichever layout you choose, you will get virtually the same results as far as you're using the same components. So you can go from like I did now. You can go to the radiator, and from the radiator to the GPU to CPU and all that, instead of doing what I did before of going directly to the CPU, then back to the GPU, and which looked like the most common sense approach. But the reality is that the heat capacity of water is quite very high. So for any temperature increase in the liquid, in the cooling fluid, the heat required to make that temperature increase is very high. And since the layout doesn't allow for a very great, the layout changes won't allow for very great temperature differences in between both layout changes. Hence, you won't see much difference in the water temperature. And that's what's being shown here. So layout doesn't affect much. And that's the conclusion I'm getting from this. Yeah, it's just going up 34.1, but that's about it. I don't think it's going to go up again. The Heaven benchmark scores are finished now for the second run, and it's about the same as it was before, 31 or whatever. So that's that. Thank you.